In the spring of 1945, American pilots began reporting something impossible, an aircraft that climbed vertically like a rocket and flew faster than anything they'd ever seen. It had no propeller, no visible means of propulsion. It would appear suddenly, attack at incredible speed, then disappear just as quickly. Allied pilots called it the Devil's Sled and feared encountering it. This was the Messerschmitt Me 163 Komet, the rocket fighter, the most radical aircraft of World War II. This is the story of how American forces discovered and captured this revolutionary aircraft, and how it nearly killed more of its own pilots than enemy airmen. To understand the Komet, we must go back to the 1930s. German aircraft designer Alexander Lippisch was obsessed with tailless aircraft. He believed that a flying wing design was more efficient than conventional aircraft. Lippisch experimented with gliders that had swept wings and no tail. These designs showed promise but lacked adequate power. Traditional piston engines were too heavy for such small aircraft. Lippisch needed a completely different form of propulsion. Meanwhile, German engineers were developing rocket technology, not for aircraft but for experimental vehicles and weapons. Rocket motors produced enormous thrust for their weight, but they consumed fuel at an alarming rate. Lippisch realized that a rocket motor was perfect for his tailless fighter concept. A short burst of incredible power was exactly what an interceptor needed. The aircraft could climb rapidly to intercept enemy bombers, make a high-speed attack, then glide back to base. The limited endurance wouldn't matter for point defense. In 1937, Lippisch joined Messerschmitt and brought his radical designs with him. Messerschmitt was interested in developing advanced interceptors. The combination of Lippisch's aerodynamics and rocket propulsion was intriguing. Work began on what would become the Me 163. The initial design was refined through wind tunnel testing. The swept wing configuration provided stability at high speeds. The compact fuselage minimized drag, but finding the right rocket motor proved challenging. Early rocket engines were unreliable and dangerous. They tended to explode without warning. The fuel was corrosive and would eat through metal. Development proceeded slowly until the war created urgency. By 1941, Allied bomber raids on Germany were increasing. The Luftwaffe needed faster interceptors to catch the bombers. Conventional fighters had to climb for many minutes to reach bomber altitude. By the time they arrived, bombers had often already struck their targets. A rocket-powered interceptor could climb to altitude in under 3 minutes. This capability made the Me 163 suddenly very attractive. The Luftwaffe ordered accelerated development and testing. In October 1941, test pilot Heini Dittmar flew the Me 163A prototype. Under rocket power, the tiny aircraft accelerated like nothing he'd ever experienced. In one test flight, Dittmar reached 623 miles per hour. This was faster than any aircraft had ever flown. The speed record stood until jet aircraft appeared later in the war. But this incredible performance came with terrifying challenges. The aircraft was extremely difficult to control at high speed. Control surfaces became almost useless above 500 miles per hour. The pilot had to fight the aircraft constantly, and the fuel was literally deadly. The Me 163 used a two-component rocket fuel system. T-stoff was concentrated hydrogen peroxide. C-stoff was a mixture of hydrazine hydrate, methanol, and water. When these two fuels mixed, they ignited spontaneously. This produced tremendous thrust but also tremendous danger. If the fuels leaked and mixed accidentally, the result was catastrophic. The T-stoff was particularly nasty. It would dissolve organic matter on contact. A single drop on skin would cause severe chemical burns. If a pilot crashed and fuel spilled into the cockpit, death was almost certain. The pilot would literally dissolve in the corrosive chemicals. Many Komet pilots died this way, not from enemy fire but from their own fuel. Despite these dangers, development continued. The Me 163B model was refined for operational use. It had a more powerful rocket motor and improved fuel systems. The armament consisted of two 30mm cannons. These weapons had devastating firepower but limited ammunition. Pilots had only about 60 rounds per gun. This meant they had just seconds of firing time. Every shot had to count. The aircraft also had no landing gear in the traditional sense. It took off using a detachable wheeled dolly. Once airborne, the dolly was jettisoned. Landing was done on a retractable skid. This saved weight, but made landing extremely difficult and dangerous. The pilot had one chance to get it right. Production of the Me-163B began in 1943. The first operational unit was formed in May 1944. Jagdgeschwader 400, or JG 400, was based near Leipzig. The unit was commanded by Major Wolfgang Später. Später was an experienced fighter pilot who understood the Komet's potential. He also understood its limitations and dangers. Training new Komet pilots was a nightmare. The aircraft behaved unlike any other. Pilots had to learn entirely new techniques. They practiced in gliders to learn the handling characteristics. Then they graduated to powered flights. Many didn't survive the training. Crashes were frequent, often with fatal results. The fuel would ignite and the pilot would be consumed. Those who survived training became members of an elite and terrified group. The first combat mission came on July 28, 1944. A formation of American B-17 bombers was approaching Leipzig. 6 Me-163s were scrambled to intercept. The tiny rocket fighters climbed almost vertically. In less than 3 minutes, they were at bomber altitude. American bomber crews watched in amazement as these strange aircraft appeared. They looked like flying bathtubs with tiny wings, and they were moving incredibly fast. The Komets flashed through the bomber formation. Their closure rate was over 600 miles per hour. This gave pilots only a fraction of a second to aim and fire. On this first mission, no bombers were shot down. The pilots were still learning how to attack at such high speeds, but the psychological impact on Allied crews was significant. They'd encountered something they couldn't understand or defend against. Over the following months, JG 400 developed attack tactics. The standard approach was to climb above the bomber formation, then dive through at maximum speed, firing a brief burst. The dive would carry the Komet safely past the defensive fire. Then the pilot would zoom climb for another attack, but the powered endurance was only about 8 minutes. Once the fuel was exhausted, the Komet became a glider. The pilot had to glide back to base and land. This made the aircraft extremely vulnerable. Allied fighters learned to wait for Komets to run out of fuel. Then they would attack during the glide back. The powerless Komet couldn't evade or fight back. Many were shot down this way. The Me-163 shot down a confirmed 9 Allied bombers. Some sources claim more, but documentation is unclear. However, the Komet lost 14 aircraft in combat, and many more were lost to accidents and fuel-related incidents. The kill-to-loss ratio was terrible. The aircraft killed more of its own pilots than enemy airmen. Allied intelligence was desperate to learn about this mysterious aircraft. Reports from bomber crews were confusing and contradictory. Some said it had no engine at all. Others reported seeing a bright flame from the tail. Intelligence analysts struggled to understand what they were dealing with. Was it jet-powered, rocket-powered, something else entirely? The first clue came from reconnaissance photos. Photos of German airfields showed these strange tailless aircraft. They were much smaller than conventional fighters, and they appeared to have no propeller or jet intake. But photos couldn't reveal how the aircraft worked. The Allies needed to capture an intact Me-163. As Allied forces advanced into Germany in 1945, opportunities arose. American and British troops were overrunning Luftwaffe airfields. Special teams were assigned to capture German aircraft and technology. These teams were part of Operation Lusty for Luftwaffe secret technology. Intelligence officers and technical experts accompanied the advancing armies. They had lists of priority targets to capture. The Me-163 was near the top of that list. In April 1945, American forces approached the airfield at Husum. This was one of the bases used by JG 400. As troops entered the airfield, they found several Me-163s. Some had been deliberately destroyed by retreating Germans, but a few were intact, abandoned in their dispersal areas. American soldiers approached these strange aircraft with caution. They'd been warned that German equipment might be booby-trapped, but these Komets appeared to have been left in a hurry. No explosives were found. The soldiers stared at these bizarre machines. They looked nothing like any aircraft they'd seen, short, stubby, with swept wings and no tail. The fuselage was barely large enough for a cockpit, and there was no propeller, just a mysterious opening at the rear. Technical intelligence teams arrived within hours. They began documenting everything about the aircraft. Photographs were taken from every angle. Measurements were recorded. The teams carefully examined the rocket motor. It was unlike anything in the Allied inventory. The fuel system was particularly puzzling. Two separate fuel tanks fed into the motor through a complex valve system. The experts realized this must be some kind of chemical rocket, but they didn't yet understand the extreme danger of the fuel. That lesson came soon enough. One captured Komet still had residual fuel in its tanks. An American technician was examining the aircraft. He accidentally punctured a fuel line. A small amount of T-stuff splashed onto his hand. Within seconds, he was screaming in agony. The chemical burned through his skin. Medics rushed him to treatment, but the damage was severe. From that moment, Allied personnel treated Komet fuel with extreme caution. More Me-163s were found at other locations. The factory at Clem had several in various stages of assembly. British forces captured examples at Bad Zwischenahn. The Soviets captured others as they advanced from the east. All three major allies wanted to study this revolutionary aircraft. The Americans selected the best examples for shipment to the United States. These were carefully disassembled and packed for transport. Everything had to be documented so the aircraft could be reassembled. The rocket motors were given special attention. American rocket experts were fascinated by the German technology. The Walter HWK 109509 motor was examined in detail. It was a remarkably compact and powerful engine. The thrust chamber design was particularly clever. It extracted maximum performance from the dangerous fuel combination. American engineers learned valuable lessons from studying this motor. The intelligence teams also sought out German personnel. Pilots, mechanics, and engineers were interrogated. Some were eager to share information, hoping for favorable treatment. Others were reluctant, still loyal to Germany even in defeat. But gradually the full story of the Me-163 emerged. The Allies learned about its development history. They discovered the casualties among German pilots. They learned about the fuel hazards and operational limitations. And they understood why, despite its speed, it hadn't been more successful. One of the most valuable finds was a complete set of technical manuals. These documents explained every system in detail. Maintenance procedures, operational limits, and safety precautions. The manuals were translated immediately and distributed to intelligence agencies. Several captured Me-163s were shipped to Wright Field in Ohio. This was the Army Air Force's testing and evaluation center. Engineers reassembled the aircraft and prepared them for examination. The first question was whether to attempt flight testing. Flying the Komet would provide valuable data. But it was extremely dangerous. American test pilots would have to master an aircraft that killed its own pilots regularly. After much debate, the decision was made not to fly the captured Komets. The risks were simply too great. The fuel was too dangerous to handle safely, and the operational life of the motors was very short. Instead, the aircraft were subjected to ground testing. The rocket motors were test-fired on stands. Engineers measured thrust, fuel consumption, and operating temperatures. The airframe was examined in wind tunnels. The swept-wing design showed interesting aerodynamic properties. It delayed the onset of compressibility problems at high speeds. This was valuable data for American high-speed aircraft development. The British took a different approach with their captured Komets. They were determined to fly the aircraft. Several Me-163s were shipped to the Royal Aircraft Establishment at Farnborough. The British built a small supply of rocket fuel following German formulas. Extreme safety precautions were taken during fuel handling. Personnel wore protective suits that looked like spacesuits. Even a tiny fuel spill could be catastrophic. Test pilot Eric Brown was selected to fly the Komet. Brown was one of Britain's most experienced test pilots. He had flown more types of aircraft than perhaps anyone else. But the Me-163 was unlike anything he'd encountered. Brown first flew the Komet as an unpowered glider. He was towed to altitude by another aircraft, then released. The handling was tricky but manageable. The swept wings made it more stable than expected. But landing on the skid was challenging. The pilot had no second chance. You landed or crashed. Brown practiced glide landings until he was confident. Then came the moment for a powered flight. The Komet was fueled under strict safety protocols. Everyone not essential cleared the area. Brown climbed into the tiny cockpit wearing protective clothing. He started the motor and felt the aircraft shudder. The rocket ignited with a roar unlike any piston engine. The acceleration was violent and immediate. Brown was pressed back into his seat by forces he'd never experienced. The Komet left the ground almost instantly. It climbed at an angle that seemed impossible. Within seconds, Brown was at 10,000 feet. The speed built rapidly to over 500 miles per hour. Control was difficult at this velocity. The aircraft wanted to pitch and roll unpredictably. Brown had to fight it constantly. Then, after just a few minutes, the rocket motor cut out. The fuel was exhausted. Suddenly, the Komet was a glider, silent except for the wind. Brown had to glide back to the airfield and land. He circled carefully, judging his approach. The landing had to be perfect. He came in low and fast, flared at the last moment. The skid hit the grass and the Komet slid to a stop. Brown climbed out, shaken but exhilarated. He'd flown the rocket fighter and survived. Brown's report confirmed what German pilots had said. The Me-163 was incredibly fast, but almost impossibly difficult to fly. The powered endurance was too short for effective combat, and the fuel was so dangerous that operations were a constant hazard. The British concluded that rocket fighters were not practical. Jet engines were a better path to high-speed flight. They provided sustained power without the fuel dangers. The Soviets also captured and tested Me-163s. They were interested in rocket technology for their own programs. Soviet engineers studied the Walter rocket motor carefully. They even built copies and tested them in Soviet aircraft. But like the British and Americans, they concluded jets were better. The information gathered from captured comets was shared among Allied nations. Technical reports circulated through intelligence channels. Aircraft designers studied the swept-wing configuration. This design would influence post-war jet fighters significantly. The North American F-86 Sabre used swept wings. So did the Soviet MiG-15. Both designs benefited from German research captured at war's end. The rocket motor technology also had applications, not for aircraft propulsion, but for assisted takeoff. Post-war military aircraft used rocket-assisted takeoff systems. These were based partly on German rocket technology. The Me-163 also influenced space program development. The concept of a piloted rocket vehicle was proven. Later experimental aircraft like the X-15 followed this path. They were rocket-powered and designed for high-speed flight. The X-15 pilots learned lessons from Me-163 experiences. Meanwhile, surviving German Komet pilots had different fates. Some were captured and interrogated by the Allies. They provided first-hand accounts of flying the rocket fighter. Their descriptions were harrowing. They spoke of friends who died in fuel explosions, of pilots dissolved by T-stop after crash landings, of the terror of landing without power on a single skid. Yet they also spoke with pride about their aircraft. They'd flown faster than anyone else in the world. They'd piloted the most advanced interceptor of the war. This pride was mixed with relief that the war was over. Many admitted they wouldn't have survived much longer. The casualty rate among Komet pilots was unsustainable. Major Wolfgang Spater, the JG-400 commander, survived the war. He was extensively interrogated by American intelligence. Spater provided detailed information about Komet operations. He was candid about the aircraft's limitations. In his view, the Me-163 was a technological marvel that came too late. If it had been available in 1943, it might have mattered. But by 1944, Germany's situation was hopeless. No single weapon could change that. Alexander Lippisch, the aircraft's designer, also survived. He was brought to the United States under Operation Paperclip. This program recruited German scientists to work for America. Lippisch continued working on advanced aerodynamics. He influenced American supersonic aircraft design. His delta-wing concepts appeared in several experimental aircraft. The captured Me-163s had various fates after testing. Some were placed in museums. The Smithsonian National Air and Space Museum has one. Visitors can see this radical aircraft up close. It looks almost alien even today. The stubby fuselage and swept wings seem impossibly small. It's hard to believe anyone flew such a machine into combat. Other captured Komets were simply scrapped. Once their intelligence value was exhausted, they had no purpose. A few ended up in private collections or aviation museums worldwide. Today, only a handful of Me-163s exist. They're rare artifacts of one of aviation's most radical experiments. The story of the Komet's discovery fascinated the American public. Newspapers ran stories about the rocket plane without a propeller. The aircraft became a symbol of German technological desperation. It showed how far Germany would go to try to win the war. Building an aircraft that killed its own pilots was seen as madness. But it also demonstrated German engineering brilliance. The Komet was genuinely revolutionary. No other nation had developed anything comparable. This caused concern in military circles. What other secret weapons might Germany have developed? The hunt for German technology intensified. Teams scoured captured territories for research facilities. They found jet engines, guided missiles, and advanced submarines. The Germans had been pursuing multiple revolutionary technologies. The Me-163 was just one example. For Allied airmen who'd encountered the Komet, the capture brought closure. They'd faced something they couldn't understand or counter. Now they could see it up close and understand what it was. Many bomber crews visited the captured Komets. They were amazed at how small and fragile the aircraft looked. This tiny machine had seemed invincible in the air. Seeing it on the ground was strangely reassuring. It was just metal and chemicals, not magic. The technical intelligence from the Me-163 program was extensive. Reports filled volumes. Every system was documented in detail. The aerodynamics, the propulsion, the fuel system, the control systems, the armament, the landing gear. Engineers studied the construction methods. The Komet was built from welded steel tube and wood. It was designed for rapid production with limited resources. About 370 Me-163s were built during the war. This seems like a small number, but given the specialized nature and late introduction, it's significant. The aircraft was so difficult to operate that training couldn't keep up. Many built Komets never saw combat. They sat at bases waiting for qualified pilots who never came, or waiting for fuel that was increasingly scarce. Germany's chemical industry was being destroyed by Allied bombing. Producing the exotic rocket fuel became more difficult. By war's end, fuel shortages grounded many Komets. The aircraft were available but couldn't fly. This made them easier for Allied forces to capture intact. Looking back, the Me-163 represents both genius and folly. The engineering was brilliant. Creating a functional rocket fighter in the 1940s was remarkable. The aircraft achieved performance that wouldn't be matched for years. But it was also profoundly impractical. The powered endurance was too short. The fuel was too dangerous. The landing method was too risky. And the training requirements were too demanding. Germany would have been better served by more conventional fighters. The resources spent on the Me-163 program could have built hundreds of Bf-109s. Those conventional fighters would have been more effective. But that practical assessment misses something important. The Me-163 pushed the boundaries of what was possible. It proved that rocket-powered flight was viable. It demonstrated swept-wing advantages at high speed. It showed that radical aircraft designs could work. These lessons influenced post-war aviation development. The captured Komets served as inspiration and warning. They showed what could be achieved, but they also showed the dangers of pushing too far too fast. American test pilots who examined the Komet had mixed reactions. They admired the boldness of the design. They respected the German engineers who created it. But they were also appalled by the casualty rates. No American aircraft would be acceptable with such losses. The US military valued pilot lives too highly. Germany, desperate by 1944, was willing to accept higher risks. This difference in values showed in aircraft design philosophy. American aircraft prioritized pilot safety alongside performance. German late-war designs often sacrificed safety for capability. The Me-163 was an extreme example of this trade-off. The discovery and capture of the Komet had strategic implications. It demonstrated that Germany had been pursuing advanced technologies. This knowledge shaped post-war military planning. The US and Soviet Union both prioritized advanced aircraft development. They recruited German scientists and engineers aggressively. The emerging Cold War made German expertise valuable. Both superpowers wanted to benefit from German research. The Me-163 became a symbol of this technology transfer. For aviation enthusiasts, the Komet remains fascinating. It represents the extreme edge of World War II technology. Books and documentaries have explored its story. Model companies produce detailed replicas. The distinctive shape makes it instantly recognizable. It looks futuristic even today, 8 decades later. The captured Komets also contributed to public understanding of rocketry. In the late 1940s, rockets were mysterious and exotic. The Me-163 helped demystify rocket technology. It showed that rockets could be practical propulsion systems. This prepared the public for the space age to come. When rockets began launching satellites in the 1950s, the concept wasn't completely foreign. People had seen photos of the Me-163 and knew rockets worked. The pilots who flew the Komet became legends in aviation circles. They'd experienced something no one else had, flying at speeds that seemed impossible in unpowered gliding flight, climbing vertically on a pillar of flame, facing death from both enemy fire and their own aircraft. Those who survived carried unique memories: the terrifying acceleration as the rocket ignited, the roar that filled the cockpit, the world dropping away as the Komet climbed, the sudden silence when the fuel ran out, and the tense moments of landing on a single skid. These experiences were unlike anything else in aviation. The American capture and study of the Me-163 was part of a larger effort. Operation Lusty collected hundreds of German aircraft, jets, rockets, and advanced piston engine designs. All were evaluated to extract their secrets. This massive intelligence operation advanced American aviation by years. Technologies that would have taken a decade to develop were acquired instantly. The Me-163 was one of the most valuable prizes, not because it was a practical aircraft design, but because it represented radical thinking and advanced engineering. It showed American engineers what was possible, and it provided data that would prove valuable for decades. The swept-wing research alone justified the effort. American aircraft designers had been exploring swept wings, but German research was years ahead. The captured data accelerated American programs significantly. The first American swept-wing fighter, the F-86 Sabre, benefited from this research. It became one of the most successful fighters of the Korean War. The lineage from Me-163 to F-86 is indirect but real. German research informed American design decisions. As we reflect on the Me-163 story, several themes emerge. First, the power of desperation to drive innovation. Germany, facing defeat, pursued radical technologies. The Me-163 would never have been built in peacetime. Second, that technological superiority alone doesn't guarantee victory. The Komet was the fastest fighter in the world, but it had minimal impact on the war's outcome. Third, that revolutionary designs come with revolutionary risks. The Me-163's casualty rate among pilots was unacceptable. Innovation must be balanced against practical concerns. Fourth, that captured technology can be immensely valuable. The Allied study of German aircraft advanced their own programs. Intelligence collection at war's end shaped the post-war world. And finally, that boldness in design can inspire future generations. The Me-163, for all its flaws, pushed boundaries. It showed that radical aircraft could fly. This encouraged later designers to think beyond conventional limits. The American pilots who first reported the strange propellerless aircraft couldn't have imagined the full story. They'd encountered the Me-163 Komet, Germany's rocket fighter, a desperate weapon born from desperate circumstances. The capture and study of this aircraft revealed its secrets, the genius of its design and the madness of its operation. For the German pilots who flew it, the Komet was a death trap and a marvel. For Allied intelligence, it was a treasure trove of advanced technology. For aviation history, it represents a remarkable moment, when an aircraft designer dared to build something truly revolutionary, when pilots risked everything to fly it, and when enemies captured and studied it, learning from both its brilliance and its failures. The Me-163 Komet flew faster than anything else in World War II, but it also killed more of its own pilots than enemy aircraft. It was unbelievably fast and incredibly dangerous to fly, the odd German plane without a propeller that American pilots discovered. Today, the few surviving Me-163s sit in museums, silent witnesses to one of aviation's most audacious experiments. Visitors stare at the small, stubby aircraft with its swept wings. They see the opening at the rear where the rocket motor once roared. They imagine what it must have been like to climb vertically on a pillar of flame, to race through the sky at speeds beyond comprehension, and to land on a single skid, knowing your fuel could explode at any moment. The capture of the Me-163 by American forces in 1945 was more than just a military operation. It was a transfer of knowledge from one generation to the next. German engineers had pushed rocket technology to its limits. American engineers learned from their success and their failures. The lessons shaped aircraft design for decades. They influenced the development of supersonic fighters, They contributed to rocket plane experiments like the X-15. They even played a role in early space program development. The idea of a human riding a rocket into the sky was proven by the Me-163. It was dangerous, yes, but it was possible. The German pilots who flew the Komet were true pioneers. They experienced flight in a way no one had before. The acceleration, the speed, the vertical climb, these were sensations that wouldn't become common until the jet age. And even then, few jets matched the Komet's raw performance. The price paid for this pioneering was high. Pilots died in training accidents, fuel explosions, and combat. The exact number of Komet pilot casualties is disputed. But it was certainly higher than the number of enemy aircraft they destroyed. This grim statistic defined the Me-163's legacy. It was a weapon that harmed its users more than its targets. Yet it also represented human courage and determination. The pilots who climbed into the Komet knew the risks. They'd seen comrades die in training. They understood the fuel could dissolve them if they crashed. But they flew anyway, driven by duty and perhaps a love of speed. The American discovery and capture of these aircraft brought this story to light. Without the captured Komets, much would have remained secret. The aircraft would have been destroyed in the war's chaos. The technology would have been lost. The stories of the pilots would have died with them. Instead, the Me-163 was preserved and studied. Its secrets were unlocked and shared, and its story became part of aviation history. The intelligence officers who organized the capture operations understood the value. They knew German technology was advanced in certain areas. The Me-163 was a prime example. Nothing else in the world could match its speed in 1945. Understanding how it worked was a priority. The technical teams that examined the captured aircraft were thorough. They measured, photographed, and documented everything. They tested components to understand their function. They interviewed anyone who had worked with the aircraft. The result was a comprehensive understanding of rocket fighter technology. This knowledge informed American military planning for years. Looking at the Me-163 today, it seems almost primitive. Modern aircraft are far more sophisticated. They have advanced avionics, guided weapons, and reliable jet engines. The Komet had none of these advantages. It was essentially a manned rocket with guns. But in its time, it was revolutionary. It proved concepts that seemed impossible. Rocket propulsion for aircraft was viable. Swept wings improved high-speed performance. Tailless aircraft could be stable and controllable. These lessons influenced generations of aircraft designers. The story of the Me-163 is ultimately a human story. It's about engineers pushing the boundaries of technology, about pilots risking their lives to fly experimental aircraft, about soldiers capturing enemy technology in the chaos of war, and about how knowledge is transferred between adversaries. The Americans who first encountered the Me-163 in combat were terrified. They faced something beyond their experience, an aircraft that seemed to defy the laws of physics, that climbed impossibly fast and flew at incredible speeds. The Americans who captured the Me-163 gained understanding. They saw that it was just an aircraft after all. An extraordinary aircraft, yes, but bound by the same physical laws. This knowledge removed the fear and mystery. The Americans who studied the Me-163 gained wisdom. They learned what worked and what didn't. They understood the trade-offs in the design. The incredible speed came at the cost of endurance and safety. This wisdom informed future aircraft development. American designers would pursue speed, but not at any cost. They would seek balance between performance and practicality. The Me-163 showed them the extreme. Now they knew where not to go. For the German engineers who designed the Komet, the war's end brought mixed feelings. They'd created something remarkable, but it had failed to save their country. Many were recruited by the victorious Allies. They continued their work under new flags. Their expertise helped America and Britain develop advanced aircraft. The knowledge they carried wasn't lost. It was transferred and transformed. The Me-163 technology became part of the Western aerospace tradition. As we conclude this story, we return to that spring day in 1945, when American pilots first encountered the impossible, an aircraft with no propeller, climbing vertically, flying faster than anything should. Their reports sparked a hunt, a race to capture and understand this mysterious weapon. The success of that hunt yielded valuable intelligence. The Me-163 Komet was revealed as a triumph and a tragedy, a glimpse of aviation's future wrapped in World War II desperation. The American pilots, soldiers, and engineers who discovered and captured these aircraft played a crucial role. They preserved knowledge that might have been lost. They advanced their nation's aerospace capabilities, and they ensured that the story of the Komet would be remembered. The odd German plane without a propeller, unbelievably fast, incredibly dangerous, and absolutely revolutionary. The Messerschmitt Me 163 Komet, captured by American forces at the end of World War II. A rocket fighter that changed aviation history, not through its combat successes, which were few, but through the knowledge it provided to those who studied it. The legacy of the Me 163 lives on in every swept-wing jet, in every rocket plane that pushed the boundaries of speed, and in the understanding that revolutionary design requires revolutionary courage. This is the story of American pilots who found an odd German plane and discovered it could fly without a propeller, faster than anything in the world. The story of how Americans captured and studied the Me 163 Komet and learned the secrets of the rocket fighter,